Hello everyone, this is a getting started video on the firmware development for VALTRACK-V4-VTS-ESP32-C3 based devices. So this video will get you started on firmware development with the VSCODE IDE and ESP-IDF framework. So we will be needing the VSCODE IDE for this because the firmware development is done on it, and we will skip the installation of VS Code in the video. You need to download the VS Code from the website and install it before getting started on this. So after you install the VS Code, we will show you the next steps now.
Once you install VS Code, we need to install ESP-IDF framework now. Open VS Code, and after this you can go into extensions and search ESP-IDF. Click on this and install. Once the installation is done, it will show up with the home page folder for settings. If you don't find it, just click on this search here and write arrow mark and ESP-IDF, configure ESP-IDF extension. Now click on Express, select Expressive instead of GitHub, it's faster. Select version 4.4.4 and give this path. I have created a folder called C/ESP in C drive, just ESP folder, and then click on install. Okay, once it's complete, it will show this page that all settings have been configured. You can close this window. You can close this window now. Now we need to get our code to get started with development. So let's go to docs.valetron.com. We have to open VALTRACK-V4-VTS-ESP32-C3, and here in the left menu you can go to firmware. Here I have posted the link for the GitHub repository. So now here you need to download this code. Download zip. I will extract it. Extract the zip to any folder you want. I will extract it to ESP32-C3 master, and everything will appear in this folder here. So now I will go to VS Code again and go to Explorer, open folder, and select this folder from whatever we downloaded now. Okay, now we can expand our code. So this is all the code is in main.c. It's still not organized. So once you got this, you can select the COM port where your device is detected. My device is detected as COM4 here. You will get the COM port from the device manager. So it will appear as USB serial device COM4. So select COM4 from the left menu here. COM4 is available. Click. And then you can select the processor. Here our processor is ESP32-C3. You can also select it if it's not already selected. Select the built-in USB JTAG. Click on build project. There is the build button in the bottom here. Click on this. If you encounter any errors during the setup, make sure your build folder is empty when you are doing it for the first time. Click on build. Okay, once you see this, it means that the compilation is complete. You can see that how much amount of memory is used. It's saying 39.8% memory is used. So we will go ahead and flash the chip. Now you can use this flash button here in the bottom. It says ESP-IDF flash device. Click on this and the programming should start, and in no time your chip will be programmed. Now since we are using the onboard USB, we can even look at the terminal data. There is this terminal button, ESP-IDF monitor device. When you click on it, it will show up this. So initially it will show up some boot information, like what kind of boot it was and everything. So it says not a deep sleep reset, wake up reason, and the motion sensor which was not detected. It will start printing some data here. These are actually system timer, motion timer, front panel timer, and the motion sensor interrupt. So then there is the voltage of the main battery. It's 12 volt or 3.7 volt. This V will always indicate the 12 volt battery input. Now I have not connected the 12 volt battery input, so it's giving 0.4. And this is the head index and the tail index. These are used for the circular buffer to show how much data is available in the circular buffer to be sent. And this is the GPS status. V means no signal, and if it's G equal to A means the GPS signal is acquired. C is actually charging status. It's used in V4MF devices. So this string is actually being printed from, and now we can go to in outline, we can search for app_main. Now in this outline you can go to app_main. So this is where the program execution starts. In the first there is system init, then there is, it prints the sleep, wake up reason, why it was woken up, whether it was motion input or whether it was a reboot, power reboot, or an RTC reset. And there are three tasks basically. There is a ADC task, start timer task, and main task. So timer will just do some housekeeping work, like running some timers in the background, and then there is this main task where all the execution and all the core code is where the data transmission, reading and writing happens. So ADC task is actually just reading the ADC pin and putting it into a buffer. So let's look at start main task. So here the execution starts and it prints the boot reason and goes ahead and initializes all the LEDs. Update network is actually updating the network LED. By update battery is updating the battery LED. And then we enable the GSM and enable the power key pins so that the GSM module boots up and start the initialization process. So we are reading the EEPROM parameters, but in this device there is no EEPROM, so we are just reading it from the onboard flash. So we still need to implement the flash writing libraries. So right now we are just reading the data that's on the flash. Then we initialize the accelerometer, then the initialize GSM modem and check for signal strength. And then here we post a reboot ping to the circular buffer, and here we go and check whether we need to enter deep sleep and everything. So here at the bottom you can see that the code is there for transmission of the data. So here it is. So suppose if it's the working, initially the working mode will be in H means HTTP. So here you can see that so here when we come here we can see that if the based on the module selected, we call that respective data transmission function. So HTTP request is actually doing HTTP post request for SIM7600 module. If you just want to quickly get started, you need to go to this default parameters function. Here you find all the default values. So this all parameters control the whole transmission thing. So here the first field is the ping interval. It controls the data interval at which the packets are sent. So this is at 10-second intervals now. Then there is this working mode. Working mode is actually whether it can be TCP or HTTP. We have left it for default as HTTP. And the motion alert mode is not used. So, and then there is motion threshold. It's the accelerometer motion threshold value for LIS3DH accelerometer sensor. Then there is the next field is the HTTP URL. So you can find the variable name at the end of these strings. Then there is the HTTP key that will be sent in the header field of the post request. Then the next parameter is the APN, and then there is the APN username, APN password for your SIM card. Then there is this if the working mode becomes TCP here, then these parameters will come into effect, and the code will start using the MQTT functions to transmit the data. So here this is your MQTT host, port number, and client ID, topic, and the protocol name. So usually we don't change these values, they are default for the MQTT protocol. So you just need to change your host, port number, client ID, topic, that's all. And there is the MQTT username and password also if you are sending any authentication information. So once you do this, everything, the device will automatically start sending the data for whichever mode you have selected. Then if you are doing some configuration, all the settings are left in sci.h. So go to include and sci.h. So here all the settings are there. So if you are using a VTS device, select uncomment VALTRACK-V4 VTS. If you are using V4MF or V4MFW, uncomment that one and the comment other things. So we are using SIM7600 series modem. So A7672 is also a 7600 series modem. So the commands are compatible. And then here we are enabling the external antenna because we are using the internal GNSS of the A7672 module. Then we are enabling motion control pings. We want the modem to go to sleep if there is no movement for 5 minutes. And we are using pin control LEDs. We are not using IO extenders. The earlier versions used an IO extender for controlling the LEDs. So this one is directly pin controlled, and we have hash defined all the pins here. The TPS 54240 main power supply enable pin has been connected to GPIF4 of ESP32-C3. So you can totally shut down the main battery input if there is internal battery present using this GPIO. But be careful when you do that, the internal battery has to be there. If the internal battery is not connected and you enable the TPS enable pin, then you will put the device into race around condition and might damage the device. So only when you have the internal battery connected, then only you can control this. Then there is this timers for some housekeeping. So if the modem doesn't respond for a while, then it will reset it. And then we have this settings here for the range of LEDs. So for the VTS device, the ranges are like this. If the voltage is in between this range, then it's red. If it's in this range, then it's blue, then in green. So here for V4MF, it is lithium ion battery voltages from 3.7 to 4.2 volts, red, green, and blue. And the packet count is basically the maximum number of packet it can try to push into a single HTTP post request. So I kept it at 3. If suppose some packets are delayed and we need to send it fast, so we can club 3 of them together and send it. Then these are the default baud rates, and the accelerometer is LIS3D enabled, and we are setting the accelerometer addresses here. And the ADC reference voltage is 3.3 volt because the control is running at 3.3 volts. And then there is these are all ADC parameters. Then this is the time to sleep. So after this many amount of seconds, after 300 seconds, the modem will go into sleep mode if there is no motion detected. And these are the UART settings for the cellular modem port. So we are using UART 1 with on pin 0 and 01. So you can explore more things as you go through the code. This is all you need to get started. So you can see all the logs, what's happening between the modem and the MCU here. So all the transactions are happening here. So this log is printed in start timer task. Here it is on line number 2572. So here I am printing everything. So SC is actually sleep mode enabled, and these are all the parameters that are being printed. I will make more tutorial with the in-depth information of this firmware. This firmware has been written over the years and it's very unorganized as of now. We will organize it, get into different files, but this should get you started on the hardware. Thank you for watching. Don't forget to like, share, and subscribe.